Alright, let's try looking at and sketching another rational function where the numerator is 1 degree higher than the denominator, right? So it's axn plus 1, bxn plus d. Okay, so we're going to take a look at this and we're just kind of basically describe how to sketch this by looking at the domain, range, asymptotes, intercepts, and behavior. We need to note that when the degree of the numerator is 1 higher than the denominator, we know that there is the presence of an oblique asymptote, right? So just by looking at, if we wanted to look for the oblique asymptote, we can find the quotient of the function. Now just off the bat here, we can notice that the domain of the function, x can belong to all real numbers, right? But we know that the 2x minus 5 cannot equal 0, so if I move the 5 here, 2x cannot equal 5. If I divide by 2 to both sides, to solve for what x cannot equal 5 over 2. Right, so x cannot equal 5 over 2. This is the restriction on the domain. Alright, so, and we can understand that if the degree of the numerator is 1 higher than the denominator, the range y can belong to a set of all real numbers. Okay, so there is no horizontal asymptote. Okay, so keeping this in mind, we, however, can have a vertical asymptote at x is equal to 5 over 2. We have no horizontal asymptote that exists. However, we can have an oblique asymptote. So let's determine the oblique asymptote. So to find the oblique asymptote, you're going to have to divide, right? So you're doing negative 4x squared. The numerator becomes your dividend, negative 4x squared minus 4, and your divisor is your denominator, so 2x minus 5. And then you want to match your leading term. In this case, it's negative 4x squared. So I'm going to multiply this by negative 2x. So you get negative 4x squared plus 10x. And then you subtract these two, right? So these two cancel out. And you basically get negative 10x minus 4. And I'm going to multiply this by negative 5. So you get negative 10x plus 25. Now we don't care about the remainder. This is the only portion that we do care about. And this is the quotient, right? So the oblique asymptote is the quotient. In this case, it's y is equal to negative 2x minus 5. Now what we could do here, the oblique asymptote is a linear equation. To really plot this out really quickly, let's find our x and y intercept of our oblique asymptote. So I want to find the x-intercept. I'm going to let y equal 0. Negative 2x minus 5 is equal to 0. Move the 5 to the other side. Negative 2x is equal to 5. X is equal to negative 5 over 2, right? So the x-intercept is negative 5 over 2 and 0 of the oblique asymptote. In the y-intercept, because this is slope-intercept form, it's just equal to negative 5, right? Because you got to think about it as y is equal to mx plus b. And the b term here is your y-intercept. Okay, so we understand that. Now that you have these 2 points, and we have our asymptotes, we can also find the intercepts of our function. So let's find some of the intercepts of our function. Okay, so I'm going to start with my x-intercept. So for the x-intercept, you just let the numerator equal 0. So I'm going to factor out 4 here. You get x squared plus 1 is equal to 0. And you can notice that when you get x squared plus 1, you actually won't get an intercept, right? Because this is not solvable. X squared plus 1 is equal to 0, right? X squared is equal to negative 1, but x squared cannot equal negative 1, right? We can understand that. And because x squared will always give you a positive value. So you can imagine there is no x-intercept. You can't solve for it. Let's look for the y-intercept. So if you're trying to find your y-intercept, I'm going to let x equal 0. So you're basically plugging in f of 0 into your function. If you plug in f of 0 into your function, you get negative 4 times 0 squared minus 4 over 2 times 0 minus 5. And you basically get 4 over 5. So it's like 0 and 4 over 5. 4 over 5 is like 0.8, right? And now all we have to do is we have to sketch this on our grid. Okay? So here's my grid, and I want to plot the vertical asymptote, which is 5 over 2. That's like 2.5, right? Let's do vertical asymptote in blue. So 2.5, let's say this middle part is 3. So 2.5, let's say it's somewhere here. Okay, so guys, just try to use a ruler for this. Okay, try to make it as straight as possible. Anyways, the vertical asymptote here is x is equal to 5 over 2. And the horizontal asymptote, we don't have one, right? It doesn't exist, and we need to find our oblique asymptote. So our oblique asymptote, we can plot this based on our intercepts. I'll keep it consistent with this lime green. We have this negative 5 over 2, so it's negative 2.5. Let's say it's like somewhere here. And we also have this y-intercept of 0 and negative 5, so let's say it's like somewhere down here. Okay, so, and then what you could do is you can kind of connect the points. Okay, that's our graph, and you can imagine that there is going to be a point, there is going to be a graph that's going to exist there, right? And then we can plot our y-intercept of our graph. So it's 4 over 5, 4 and 5, so 0.8. Say it's somewhere here, right? So this is 0 and 4 over 5, and there is no x-intercept, so we can just have an idea. Whoops. Maybe make this more narrower, right? So we can kind of imagine that our curve looks like that. Okay, and you should see that another curve exists here, right? So that's the idea, really, right? And let's take a look at our end behavior. Should have made a much more smaller graph here, but it's okay. We look at our end behavior. We can understand that as x approaches negative infinity, so as we go this way, right? As we go this way, we can notice that it should be to the left of the vertical asymptote, right? So in that sense, as x approaches negative infinity, we can see, we can follow this trace here, y will go to positive infinity. Okay. As x approaches, now we're going to approach the vertical asymptote. In this case, we're going to approach 5 over 2 from the left side, right? So as x approaches 5 over 2 from the left, y will approach, and we can follow the trace very left of the vertical asymptote. You can see that it also approaches positive infinity. Now as x approaches, we'll approach the vertical asymptote from the right side, so 5 over 2 from the right. Right, we can also see, this this small orange trace. Sorry guys about the image here. I know I should have made a much more smaller scale, but it's okay. I think you can see this. You can see that this is going to negative infinity, right? So x is going to, so as x approaches the vertical asymptote from the right side, y is going to approach negative infinity. And as x approaches positive infinity, as we're going out this way to positive infinity, you can see that this trace is also going to negative infinity. Okay, so that's the idea of our rational function, where the degree of the numerator is 100.